Are there real-life space monsters? Well, of course, there are no huge beasts made of stars that are flying through the universe. However, there are some things in space that truly remind us of things from our nightmares. The first one is the Eagle Nebula, also known as Messier 16 or Star Queen Nebula, a wonder located in the constellation Serpens. This dazzling nebula was discovered in the 17th century and earned its nickname from the visual impressions it creates. If you look at it, it resembles a giant eagle flying through the universe. It's a young star cluster, located super far away, about 5,700 light-years away from Earth. The Eagle Nebula spans a region of about 70 by 50 light-years in size. For comparison, our entire solar system is only 2 light-years long, with the distance between the Sun and Pluto being only around 5 light-hours. This enormous nebula is home to more than 8,000 stars. One of them is especially bright. It's a duo of massive stars, one about 80 times heavier than our Sun, and the nebula is actively creating new ones. Every day, the gas and dust in there are being compressed by the intense radiation and stellar winds from hot, massive stars within the cluster. This triggers the birth of new stars. And finally, in the heart of this nebula lie the iconic Pillars of Creation. These are vast columns of dust and gas, seen in blue, red, and green hues. They serve as active stellar nurseries. The dark clouds slowly draw together to birth the stars of the future, shaping the rich and complicated materials found in the universe. Pillars of Creation stretch about 4 to 5 light-years, so about twice as big as our entire solar system. The Eagle Nebula is remarkably interesting to astronomers. It's a wonderful place for us to study the star's birth and evolution. The grandeur of this place is amazing. However, it's more fascinating than frightening, unlike the following monsters. Quasars, captivating powerhouses, fueled by supermassive black holes at the hearts of galaxies. These black holes are millions to billions of times the Sun's mass. Matter spirals into them, forming a luminous accretion disk. Gravity within generates intense energy across the spectrum, making quasars shine brilliantly. Sometimes they can even outshine entire galaxies. These cosmic monsters have been intriguing astronomers for years. Quasars have the appearance of regular stars but have incomparable levels of energy. Their name comes from quasi-stellar radio sources. They're radiating across the spectrum: radio waves, visible light, ultraviolet light, X-rays, and gamma rays. We've been catching their signals for many years, but first glimpsed them only in the 1960s. Quasars are one of the most ancient objects in our universe. Their light, traveling billions of light-years, helps us to learn more about the universe's early days, when these monsters were aplenty. They gradually dimmed over time, so we can only imagine how brightly they looked back then. One of the most iconic of them is Quasar Colossus. It's not one monster, it's a giant group of 73 quasars. Together, they're spanning 4 billion light-years and outshine 100 Milky Ways. Something like that is impossible for us to even imagine. Our next monster is called a pulsar. When a big star goes out of its fuel, it goes boom. What's left behind after that is a neutron star, which has a mass several times that of our Sun, but crammed into a sphere as small as a city. They're super dense. Sometimes it teams up with some friend, like a companion star. If the companion shares its stuff with the neutron star, things can go wild. The extra material might make the neutron star collapse, becoming even denser. In that case, it would turn into a so-called quark star. But if it doesn't happen, the neutron star goes a different route. This immense density means that the protons and electrons in the star collapse into each other, forming a sea of neutrons, particles without an electric charge. This is when the so-called pulsars are born. Pulsars come with an incredible magnetic flare. These stars boast magnetic fields trillions of times more powerful than Earth's. The fun begins when this super magnetized pulsar starts to spin. It's not a leisurely twirl. Pulsars can rotate hundreds of times per second. They're the fastest objects in the entire universe. As the pulsar whirls around, it shoots out beams of electromagnetic radiation. These beams act like lighthouses, sweeping across the universe with each rotation. If Earth happens to be in the path of one of these beams, astronomers detect pulses of radiation. That's where the name pulsar comes from. There's someone closely related to pulsars, the zombie stars. Sometimes, even after the star reaches the end of its life and goes supernova, it doesn't fade away entirely. Some matter might remain. In that case, it transforms into a celestial zombie. These zombie stars often appear in pairs, with one star giving in to its smaller companion. It acts like a vampire, feeding on other nearby stars. It drinks up hydrogen to come back to life. When it grows to the size of a planet, it bursts into a brilliant supernova again, destroying the star it fed on. Zombie stars aren't fussy eaters. They go beyond devouring stars. One of them is in the Virgo constellation, and it doesn't just munch on stars. It gobbles up the energy and stuff from its planets. And just like actual zombies are always on the go to find more food, these stars travel through galaxies. Recently, we found another one of them in a faraway galaxy. It's been traveling and evolving over the years, getting brighter. And this show started millions of years ago, back in the age of dinosaurs. Studying them can help us better understand how space objects work in wild conditions. It also helps us reveal secrets about fundamental particles and explore the physics of super-dense stellar leftovers. Now that we've met zombies, there are also cosmic vampires. Blue straggler stars defy aging by sucking life from their neighbors. They appear younger and bluer than their ancient companions because of that, confusing poor astronomers about their true age. Scientists studied 21 blue stragglers in a faraway 7-billion-year-old star cluster. That's when they made a breakthrough. They assumed that it was because of mergers or collisions. But then scientists revealed these sneaky stars as thieves feasting on nearby stars to stay forever young. While this discovery explains most blue stragglers, a few remain mysterious, which means that they probably have varied origins. Researchers plan to use the Hubble Space Telescope to detect their hidden companions and learn more about them in the future. Our final monster is an electric leviathan. In 2011, astronomers stumbled upon a colossal jet spewing out of a galaxy with a funny name, 3C303. It's 2 billion light-years away. What made this discovery truly electrifying was the electric current it carried, an insane 1,018 amps. For comparison, a regular light bulb can barely reach 1 amp. This is equivalent to 1 trillion lightning bolts. This jet, powered by a supermassive black hole at the galaxy's core, extended over 150,000 light-years, surpassing the Milky Way's span. This faint galaxy, first observed in the 80s, was hidden from us for a long time. We only discovered it thanks to catching different wavelengths. Typically, jets emerge from galaxies with active supermassive black holes. Only around 10% exhibit visible matter-spewing jets. The secret to the record-breaking current of this little galaxy lies in the hyperactivity of its black hole. This black hole creates a super robust magnetic field, and this magnetic field creates this electricity leviathan. So, not only we find the universe's highest electric current, but it also marked a rare opportunity to study one of these large jets. Scientists keep making their equipment better to study it in more detail, so we can learn more about them in the future. You're one out of over 8 billion people alive on Earth. Let's zoom out. Our planet is just one of 8 planets in our solar system. In the galaxy, our neighborhood is just one in almost 4,000. And from what we know so far, there are billions of galaxies in the entire universe that itself may also be growing. It's highly unlikely that we're the only living creatures in the universe. Surely there must be some other habitable planet. Here's where the Fermi paradox comes in. The idea got its name from a man named Enrico Fermi. Back in the 50s, he pointed out that if other life forms were out there and had the tech to travel through space, they should have visited us by now. These days, we have better telescopes that allowed scientists to discover over 5,000 planets outside our solar system, yet still no sign of life. Throughout the years, there have been many suggested solutions to the Fermi paradox. These outer world beings may just be too far away for a friendly chat. We've seen it in movies, spaceships traveling between stars as easily as cars on a highway. But in reality, making a way through space is a slow and cumbersome process. Even our fastest rockets would take thousands of years to reach a nearby star. When you add in the vastness of the cosmos, it's like trying to find a living needle in the biggest cosmic haystack available. We could just as easily be the very first civilization to emerge in the universe. It's a lonely thought, and it also puts a lot of pressure on us. If we're the only ones, we need to preserve life on our planet not just for our sake, but also because if we fade away, all life fades away with us. The universe has been around for billions of years, but intelligent life like ours has only existed for a tiny fraction of that time. Maybe we're just early bloomers, waiting for everybody else to catch up. To support this theory, a study was done in 2015 using the Hubble Space Telescope, and this is what it showed. Out of all the worlds that could sustain life, only 8% are as old as the Earth. The rest of them are too young and still haven't reached that point in their evolution for life to thrive. There could also be the possibility that our galactic relatives are watching us from afar. A scientist from another planet may be studying us as primitive life forms right now. He may not want to disturb us just yet, the same way we look at ants in an ant farm during science class. On that same note, maybe they're just not ready to interact with us because they've calculated a precise, perfect timing for our meetup. So they're lying dormant, in a hibernation status. And they may be right to do so. Why rush into things when we've got all of eternity ahead? There's also the idea that our planet and us humans just aren't cool enough for others to play with, and won't be until we're evolved enough to be welcomed into the Galactic High School's senior class. Or perhaps life is more fragile than we believe. A 2016 study suggested that it's in the early years of a planet where life makes its way. That's when the planet is cool enough for water to form, but those conditions may not last long thanks to the greenhouse effect. So even if life has existed in the universe every now and then, it never evolved to a stage where it could have contacted us. And what if life's ultimate test comes much later? Several thinkers believe that civilizations tend to destroy themselves at some point in their technological evolution, and this may be a potential future for us too. We're just not there yet. Maybe we'll come to build technology so smart and so powerful that it will overwhelm us, leading to our demise. If it can happen to us, who's to say it didn't happen to other species in the past, on other planets? Amidst all these theories, there's one possibility that's both sobering and profound. We may truly be alone in the universe, forever. Perhaps the conditions for life are so rare that Earth is the only oasis in a vast desert of emptiness. The creepiest answer to the Fermi paradox has a name though, and it's called the dark forest theory. It first appeared in the 1980s. According to it, the universe is a huge version of a haunted forest, and other types of creatures are out there playing a game of hide and seek. It's the expanded version of the survival of the fittest. History on Earth shows that less technologically advanced groups usually end up worse off when meeting more advanced ones. The huge differences in technology often lead to a situation where attacking first seems like the best option. If there's even a small chance that cosmic neighbors might harm us, destroying them first could be our only hope. So, if the galaxy is full of advanced life, it's smart for us to stay quiet and avoid contact. Other civilizations would probably reach the same conclusion. Even peaceful ones might feel forced to attack to survive. That's why some scientists criticize the idea of sending messages out there and think searching for them might be pointless. But this idea isn't new. A story from the 40s called First Contact describes humans meeting other types of civilizations for the first time. The two groups become friends but can't risk letting each other find their home planets. They'd rather destroy each other than risk their safety. Another story, The Forge of God, talks about the danger of our signals reaching hostile species. It compares Earth's broadcasts to a baby's cries attracting wolves. It suggests that we might be in danger because of our naivety. The Dark Forest theory was also explored in a radio play called Calls from Far Away. It shows how discovering otherworldly life on Pluto changes people's views. Some claimed the news is fake, others tried to understand the reality, that we're not alone. But it also suggests that maybe we should focus on our own problems instead of reaching for the stars. If that doesn't sound scary, this will. We've been sending signals of our existence into the cosmos for decades now. By now, any potential civilization within 100 light years of us might be getting our signals, and if they're advanced enough, they'll know exactly where to find us. If there's any reason why we need to hide from them, it's already too late. Galactic cousins aside, we do need to continue our research for habitable planets for a more pressing reason. Our cozy Earth won't be here forever. When our star fades away, all life within the solar system will fade with it. Current estimations claim we've got about 1.3 billion years left before our planet becomes uninhabitable. It will become too hot for water to exist, and without water, there is no life, at least not as we know it. It begs the following questions. What if there are other types of creatures out there that don't need water to exist? Our type of life needs water because it acts as a solvent. It's an environment where various chemicals can interact with each other to generate something that lives. Some new piece of research suggests that there may be a substitute for water out there in the universe: carbon dioxide. At certain temperatures and under a certain amount of pressure, it acts the same way, allowing chemicals to mingle. If that's true, then our list of known habitable planets would increase dramatically. Sure, we humans will probably never be able to survive on their surface, but other types of creatures may have evolved to do so. One planet that may feature these weird life conditions is closer than we think: Venus. Its atmosphere is made out of 97% carbon dioxide. It's also very hot and has enough pressure to sustain this theoretical model. Roo-row. There might be another universe, like a dark mirror image of ours, where time flows in reverse. This flipped-over world might also be the source of dark matter, the invisible substance that's all over our universe. There might also be many more universes out there, in which an exact copy of you woke up this morning, but it chose a white t-shirt instead of a red one, sending it on a completely different life path. But let's start with this elusive dark matter. It makes up most of the universe's mass, yet we're not sure what exactly it does and where it comes from. That's because it doesn't act like regular matter. We can't see it or feel it. We just know it's there because of how it seems to bend gravity. Even though regular matter and dark matter are very different, they seem to exist in a balance. Some scientists even think this must be connected somehow. A new theory suggests that for every way regular matter moves, there's a mirror version of it in the world of dark matter, like a bridge connecting the two worlds. There's a strange coincidence in regular matter where a neutron and a proton have almost the same weight. This allows them to stick together and make atoms stable, making everything that we can see with our eyes exist. If protons were a bit heavier, there would be no balance and atoms wouldn't form. In the dark mirror universe, maybe things happen differently. Perhaps in there, the equivalent of a proton doesn't bind to other particles, leaving behind lonely neutrons, which could be the source of dark matter. This theory also suggests that dark matter might have its own chemistry, like dark atoms and a dark periodic table. For the longest time, scientists believe there's just one type of dark matter. Although these particles are similar in some ways, like being almost invisible, they may vary in their sizes, speeds, and how they affect regular matter. If this idea is right, it means there could have been interactions between our universe and the dark mirror universe in the past. Studying how elements formed in the early universe might give us clues about this. This idea of a flipped world has sparked curiosity and even some confusion in the scientific community in recent years. Astronomers use a theory called the lambda-CDM model to explain the composition and behavior of our universe. According to it, most of the universe is made of two things: dark energy and dark matter. Dark energy is like a pushing force that makes the universe expand faster. Dark matter is this invisible thread that pulls things together with its gravity, acting like a universal glue. Regular objects, like stars, planets, and comets, only make up a small part of the mix. The model also tells us about the Big Bang and how everything started from a hot, crowded beginning, and how the universe has been growing and changing ever since. While this model seems to be correct in many ways, it doesn't explain all cosmic phenomena. If you were to draw this model on a piece of paper, it would look like a series of flat pancakes stacked on top of one another. Each one of the pancakes represents a rendition of the universe at a certain point in time. Yesterday's universe would stand below that of today, but it would be a slightly smaller pancake. By the end, you'll see that the universe's history looks like this giant upside-down cone, with its minuscule tip being the Big Bang. Beyond this point, we can't see any further away in time with the tools we have. So we don't know what's beyond. More so, we're still not even sure what happened immediately after the Big Bang. But if we simply apply the math, the universe might go beyond this historical tipping point, which could mean it would go in reverse, creating a similar mirrored cone where time would flow backwards, in our perspective at least. This alternative idea not only challenges our understanding of cosmic origins, but also raises questions about fundamental principles in physics. All the excitement about a mirrored universe also came from ANITA, a scientific instrument stationed in Antarctica, and its discoveries. This device saw some weird high-energy particles, seemingly bursting from beneath the Antarctic ice. The problem with these particles is they didn't behave as the laws of physics dictate. Scientists think they're a type of cosmic rays. They travel from space through the Earth and back out again. But the particles we already know about shouldn't behave like that. That's because higher energy particles usually collide with something inside the Earth, and don't come out the other side, like these do. They seem to be doing things both forward and backward. For now, there's no concrete proof of a mirrored universe. These particles could simply be ones we haven't discovered before, and scientists need to study them closely to come up with a definitive answer as to why they're behaving like this. Kind of like 4-year-olds. But what if there isn't just one other universe, but many more? This multiverse concept comes from ideas like the inflation theory, which says that our world had this rapid expansion in its early stages. While inflation stopped in our neighborhood billions of years ago, it's likely that it continues in other regions of the multiverse, creating different universes with their own laws of physics and unique characteristics. Our universe is the only one that we know of that can support life. We have stable stars that can provide heat and warmth, for example, which is crucial for creatures to start moving around. We also have an abundance of elements like carbon and hydrogen, which we also need to exist. The multiverse hypothesis gives an explanation for why our universe exhibits such life-friendly conditions. It may explain that there are countless other universes out there, with varying conditions, making the existence of life in at least one of them less likely. One fascinating implication of the multiverse theory is the idea of doppelgangers. these exact copies of individuals existing in parallel universes. This notion suggests that within the vast expanse of the multiverse, there could be infinite scenarios where identical versions of ourselves are experiencing similar events at the same time. Before we begin our travels to different universes altogether, we might still need to understand our own. There's this galaxy, AGC 104950, for instance, far from us, that might have no dark matter at all. It's about 250 million light years away and looks normal at first glance. But if we look closer, we can't seem to find any dark matter. If it turns out that there are more galaxies like this one, it could change our ideas about how galaxies are made. Dark matter is usually thought to be necessary for this process, acting like the glue that holds the whole thing together. It is true, however, that this peculiar galaxy is more faint and has fewer stars than usual. When it was first discovered in 2019, scientists thought it might not have dark matter because of how fast it was spinning. The speed at which a galaxy spins tells us how much stuff there's in it. By comparing this speed with what we can see, astronomers can figure out how much extra stuff, like dark matter, must be there. And in this unique galaxy, the math says there isn't any. Among all these theories, there's also one that says dark matter might not be real at all. This new study proposes that maybe we've been looking for something that doesn't even exist. They think that our understanding of gravity might not be good enough to explain why some galaxies behave oddly. So, instead of dark matter causing these weird behaviors, they say it might just be that we don't fully understand how regular matter works. They base these findings on a theory called modified Newtonian dynamics. It suggests that gravity behaves differently at very large distances or very low speeds. Saturn's iconic rings will disappear in less than 2 years. Soon, we won't be able to see Jupiter's great red spot. Pluto's atmosphere might vanish any day now. Even the universe itself could be slowly evaporating right at this moment. But let me start from the very beginning. Saturn's rings won't vanish forever, at least in the nearest future, but they will seemingly disappear from view. This phenomenon is caused by the planet's tilt as it orbits the Sun. As a result, the eye-catching rings adorning the gas giant will get invisible to stargazers in 2025. This outrageous disappearance occurs because Saturn's thin rings turn edge-on. It's like holding a sheet of paper horizontally at eye level, parallel to the ground, so that only the edge of the paper can be seen. Something similar happens to the gas giant's rings. As the seasons on the planet progress, instead of the southern side of the rings tilted our way, we start seeing the northern side. But then the planet tilts again, revealing the southern side once again. Such a ring plane crossing happens every 15 years, when our planet passes through the gas giant's ring plane. The last time this phenomenon occurred was in 2009. Afterward, the rings gradually became visible again over the course of several months. This time, the rings will be edge-on in March 2025. Then they will slowly come back into view and disappear again in November of the same year. Soon after that, the rings will reappear, first becoming visible to the largest telescopes, later for everyone else to see. At the same time, further into the future, the rings might cease to exist for good. Astronomers have concluded that Saturn's rings, which mostly consist of ice and rocky dust from smashed asteroids, are younger than we thought. They're losing tons and tons of mass per second all the time, and it's likely to be a few 100 million years at most before they vanish completely. Let's move to the Great Red Spot on Jupiter. This immense raging storm might stop spinning in the next 20 years. The storm in question is larger than our planet. It was first spotted in 1830, but observations from the 1600s mention the presence of a giant spot on Jupiter too. If it was the same Great Red Spot, then we can say that the storm has been raging for centuries. The storm's vortex has remained so powerful thanks to Jupiter's 400 to 600 kilometers per hour jet streams. But like any other storm, the Great Red can't keep raging forever. It has been shrinking for a long time. In a decade or two, it's predicted to turn into the GRC, the Great Red Circle. And who knows, maybe it will later turn into the GRM, the Great Red Memory. In the late 1800s, the storm was more than 56,000 kilometers across, 4 times the diameter of Earth. But when Voyager 2 flew past Jupiter in 1979, the storm had already shrunk almost twice its original size. And this shrinking is still happening. In 2017, the GRS spanned the width of a bit more than 1,635 kilometers, less than 1.3 times the diameter of Earth. Moving on, Pluto's atmosphere is going through a weird transformation. This icy dwarf planet, sitting over 4 billion kilometers away from Earth in the region of the Kuiper Belt, drew astronomers' attention in 2018 when it passed in front of a star. With such a powerful source of light illuminating Pluto, researchers managed to examine the dwarf planet and its atmosphere. They came to a shocking conclusion that Pluto's atmosphere is refreezing back onto its surface as the dwarf planet gets colder and colder. Astronomers used several telescopes in different spots in the USA and Mexico to observe Pluto and its thin atmosphere, which is mainly made of nitrogen. This atmosphere is supported by the vapor pressure of ice on the surface of the dwarf planet. For around 25 years, Pluto has been moving farther away from the Sun, and its surface temperature has been gradually going down. Pluto is really far from our star at the moment, but at one point, it will start getting closer in other regions of its incredibly huge orbit. Besides Jupiter's great red spot, Saturn's rings, and Pluto's atmosphere, we're also losing stars. But stars don't vanish, right? For thousands of years, scientists believed that lights in the sky were fixed and unchanging. Even after they realized those lights were physical objects just like the sun, they were still sure that stars went through major changes extremely slowly on timescales of millions and billions of years. In reality, though, the most massive stars, which can be hundreds of times heavier than the sun, can go through sudden catastrophic events. For example, once they reach the ends of their lives, they pass away in blinding explosions of supernovae, shining for months on end and visible across hundreds of millions of light years. But there are stars that seem to just wink out of visibility. It should be impossible. And over the past years, a group of researchers tried to figure out whether there's actually a chance of such a phenomenon happening. They started to compare data collected over decades of observations. The project is called VASCO, the Vanishing and Appearing Sources During a Century of Observations. The scientists are interested in all kinds of disappearing objects, but they are hoping to find a star that was steady and present for a long time, and then just vanished without a trace. Even if you point a super powerful telescope there, you'll still see nothing. Our current understanding of space and its laws suggests that stars change very slowly over long periods of time. Dramatic disappearances are supposed to leave noticeable traces behind. Of course, it doesn't mean that all stars should shine steadily. The sky is filled with stars that change in brightness and pulsate, but VASCO is about something very different. They want to find something that goes from a completely steady star to vanishing entirely. Such a phenomenon hasn't been documented yet, and such a discovery might lead to new physics. And now, let's move on to the most disturbing part, the one about the evaporating universe. According to a famous theory proposed by Stephen Hawking, black holes, the densest objects in the universe, evaporate over time. They lose mass in the form of bizarre radiation. But a new study claims that Hawking radiation, or something very similar to it, might not be limited to black holes. It's likely to be everywhere, and it could mean that the universe is slowly but surely evaporating right in front of our eyes. Now, Hawking radiation is something no one has ever observed, but theories and experiments suggest that it can actually exist. Let's see how it works. There's a misconception that black holes are cosmic hoovers, slurping up everything that comes too close with the help of their immense gravitational pull. In reality, though, black holes don't have more gravity than any other body of a similar mass. What they're famous for is their density, incredible amounts of mass packed into a tiny, tiny space. Within a certain proximity to such a dense object, gravitational pull becomes so powerful that it becomes impossible to escape. Not even the speed of light in a vacuum is enough, and that's the fastest known thing in the universe. At the same time, anything massive or dense enough can produce a serious curvature of space-time. In simple words, the immense gravitational field of these objects makes space-time wrap around them. Even though black holes are the most extreme example, space-time also curves around other superdense objects, like white dwarfs and neutron stars, or galaxy clusters. It means that any superdense and supermassive object can have some sort of radiation similar to Hawking radiation. And after a very, very long period of time, it could lead to everything in the universe evaporating, following the fate of old supermassive black holes. If it turns out to be true, it will change our understanding not only of Hawking radiation, but also our view of the universe and our future.
Look at this blazing monster. It's a white dwarf. These stars are known for gobbling up passing objects, and one day, these objects might be the planets of our own solar system. According to a new study, parts of the solar system will be pulled into a white dwarf star, crushed up, and eventually ground into a fine dust like coffee beans in a blade grinder. You like that analogy? White dwarfs are the final stage of a star's life. It's a small but very dense star that is typically the size of a planet, the result of a low-mass star exhausting all the nuclear fuel in its center and losing its outer layers as a planetary nebula. When our sun turns into a white dwarf, and it is bound to happen, it'll destroy the asteroids and moons around Mars and Jupiter. They will be pulverized by its gravity. Earth, though, will be swallowed up even before the sun turns into a white dwarf, but it won't happen for another 6 billion years. Researchers working on this topic have come to such conclusions by observing what happened to space bodies, asteroids, moons, and planets that were passing close to 3 white dwarfs. For 17 years, they observed and analyzed transits. That's when the brightness of a white dwarf dips because of an object in a stable orbit passing in front of it. In the case of white dwarfs, we can predict such transits and use them to study the stars themselves and celestial objects passing by them. So, when something gets too close to a white dwarf star, the star's immense gravity rips it into smaller and smaller pieces of debris. The team has also found out that transits of such debris are chaotic. Plus, this debris is oddly shaped, which means that it is being devoured further. The first white dwarf used for studying the transit process, this guy, ZTF J0328-1211, seemed steady and well-behaved over the last few years. Well, until scientists found some evidence of a massive catastrophic event that occurred in 2010 or so. The next star, ZTF J0923-4236, dims irregularly every couple of months before brightening again. And the third white dwarf, WD-1145-5+1, used to behave close to theoretical predictions. It had transits that varied in numbers, shapes, and depths, but the latest study has shown that the transits are now completely gone, and this indicates the unpredicted nature of transits. One minute you see them, the next they're gone. The reason might be the chaotic environment they have to exist in. As for our own solar system, and our planet in particular, its fate looks pretty sad. Earth will be swallowed by the expanding sun even before our star turns into a white dwarf. As for the rest of the solar system, located further from the sun, some of the asteroids between Mars and Jupiter, as well as some of Jupiter's moons, will be destroyed later. They are likely to get dislodged and travel too close to the white dwarf. At the same time, astronomers aren't 100% sure that it's exactly what will happen with our solar system. Well, I guess we'll just have to wait and see. For like 6 billion years. Speaking of white dwarfs, scientists have recently found one that has a bizarre metallic scar on its surface. This blemish could have formed after the star ripped up and ate a tiny planet orbiting it. White dwarfs with traces of metal in their atmospheres aren't rare. These traces are left by planets falling into stars affected by their gravity. Experts have long thought that such metals should be distributed evenly across the surface of such polluted white dwarfs. But a new study has discovered a white dwarf with a weird concentrated patch of metal. This star, WD 8 310, was monitored over a period of 2 months with the help of the Very Large Telescope in Chile. The researchers found an opaque patch of metal. It was located over one of the star's magnetic poles and blocked some of the star's light as it rotated. Based on this position, astronomers concluded that the material could have been funneled into the star by its powerful magnetic field. This process is similar to the one causing auroras on Earth, where charged particles follow the magnetic field to the surface. The planet destroyed by the white dwarf was most likely very small, around the same size as asteroid Vesta in the solar system, which is a mere 525 kilometers across. Its debris is now prominently displayed on the host star's surface. It makes it easier for researchers to examine what the planet's geochemistry was before it was devoured. Such a study might even turn out to be one of the best ways to observe small worlds beyond the solar system, even if such a world has already met its demise. There might be many more scarred stars like this one. The one in question was the first, but probably not the last. Even better, astronomers have already discovered 2 white dwarfs that seem to have similar scars. Making repeat observations of such stars might help us unearth, pardon the pun, no, I meant to do that, unearth even more secrets and make more discoveries. Another bizarre white dwarf, discovered not so long ago, seems to have stopped cooling due to the formation of internal crystals. It challenges existing theories on star aging and also questions the methods of stellar age estimation, but scientists might have understood why it may be happening. White dwarfs are believed to be dead stars. They keep cooling down over time, and normally this process can't be reversed or paused. But in 2019, the European Space Agency's Gaia satellite discovered a number of white dwarf stars that had stopped cooling for more than 8 billion years. It might mean that some white dwarfs can generate a lot of extra energy, which is at odds with the classical dead star theory. At first, astronomers couldn't figure out how it might happen. In the end, more than 97% of stars in the Milky Way galaxy turn into white dwarfs. Astronomers have long thought that such stars are at the end of their lives. After depleting their nuclear energy source, they stop producing heat and cool down. Eventually, the dense plasma in their insides freezes into a solid state, and the star solidifies from inside out. The whole process can take billions of years. But the new research claims that in some white dwarfs, this dense plasma doesn't simply freeze. Instead, its solid crystals forming upon freezing become less dense than the liquid and start floating upward. They displace the heavier liquid downward. The movement of heavier material toward the center of a white dwarf releases gravitational energy, and this energy is enough to interrupt the star's cooling process and halt it for billions of years. This explanation actually matches all the properties of the unusual white dwarf population. But this is the first time such a transport mechanism has been seen in any type of star, and that's incredibly exciting. A totally new astrophysical phenomenon. But why does it happen in some stars but not in others? It most likely depends on the composition of the star. You see, some white dwarf stars are formed by the merger of 2 different stars. When they collide and form a white dwarf, it changes the composition of the star, which allows the formation of floating crystals. This discovery might mean that astronomers will have to review the ways they used to determine the age of stars. At the moment, white dwarfs are often used as age indicators. The cooler a white dwarf is, the older it's believed to be. But now, we already know about possible delays in the cooling process of some dwarfs. It makes the popular age determination method more unreliable. Some stars of a given temperature may be billions of years older than we previously thought. The recently uncovered transport mechanism within white dwarfs means that some of these stars can be shining as bright as normal for billions of years. This complicates age dating and the use of white dwarfs to reconstruct the formation of our galaxy. Hey, stay tuned! Locating the North Star is quite easy on a clear night. The only thing you need to do is find the Big Dipper. Those 2 stars on the end of the Dipper's cup point the way to the North Star. See? It's the tip of the handle of the Little Dipper, or the tail of the Little Bear. It's in the constellation Ursa Minor, over there. People have been watching the North Star for centuries.
This bright star is also known as Polaris. It's situated almost directly over our planet's North Pole, which makes it a great landmark for a traveler without a compass or GPS on their smartphone. It's also Earth's closest Cepheid. That's what we call a star that pulses regularly in brightness and diameter. Polaris is also part of a binary system of 2 stars. It's got a dimmer sister. It's known as Polaris B. You can actually see it circling the North Stars from Earth. But the more astronomers watch Polaris, the less they understand. The problem is, no one can agree on how big or distant the star is. Scientists have several ways to estimate the mass, age, and distance of a star like Polaris. One method is called the stellar evolution method. After studying the brightness, color, and rate of pulsation of a star, experts use this data to figure out how bright or big it is, as well as what stage of life it's in. Once these details are clear, it's not hard to find out how far a star actually is. It's simple math once you know the luminosity of a star in real life and how dim it looks from our planet. Such models are especially precise for stars like Polaris because the rate of their pulsing is directly related to their brightness. This makes it easy to figure out the distance to any of those stars. Astronomers trust this method so much that Cepheids have become an important tool for measuring distances all across the universe. At the same time, there are other ways to study the North Star, and they don't agree with the stellar evolution models. Polaris is a so-called astrometric binary. It means you can see its companion going around it. It looks as if a circle is being drawn around the bigger star. To complete one orbit, the smaller star needs around 26 years. Even though astronomers haven't made detailed observations of Polaris B's full circuit, they've seen enough to know what its orbit looks like. Using this information, one can apply Newton's laws of gravity to calculate the masses of the 2 stars. Combined with the Hubble Space Telescope's new measurements, these calculations lead to very precise numbers. Polaris is supposed to be around 3.45 times the mass of the Sun, but that's much less than the mass you get from stellar evolution models. They suggest a value of almost 7 times the mass of the Sun. But there's another reason why this star system is weird. After calculating the ages of the stars, researchers concluded that Polaris B is much older than its bigger sibling. But it's extremely unusual for a binary system. Normally, both stars are of the same age. One explanation might be that at least one of the measurements is simply wrong. After all, Polaris is a difficult star to study. Since it's positioned above our planet's North Pole, it's outside the field of view of most telescopes. As for those telescopes that do have the needed equipment for measuring the star's properties precisely, they're typically used for studying much more distant and fainter stars. Polaris is simply too bright for such instruments. It blinds them. There's a theory that the main star of the Polaris system was once 2 stars, but they collided a few million years ago. Such a binary collision could rejuvenate stars by pulling in extra material and making the stars look as if they went through the fountain of youth. It would also explain some other oddities since stars that appear as a result of binary collisions don't fit stellar evolution models. Unfortunately, so far, none of the theories has been confirmed. The North Star is actually a big deal. Earth is spinning non-stop, which causes the sun to rise and set and stars to travel across the sky. Our planet is also tilted. That's why we have seasons. If we drew a line through the axis, Earth spins around and extended it for over 300 light years past the North Pole. At the end of that imaginary line, there would be the North Star. It stays almost exactly at the same spot in the sky at all times and always points the way north. It's really important for navigation. People heavily relied on it in the days before GPS. If you were standing on the equator, Polaris would be right at the horizon. At the North Pole, it would seem to be right over your head. In other words, using the star's height in the sky, you can not only figure out the needed direction, but also understand where you are on Earth. Curiously, there's no South Star. There isn't a bright enough star right above the South Pole. But one day, we might get such a star. When you spin a top on the table, its end moves in a circle. We know this phenomenon as precession. Earth behaves in the same way, and the North and South poles won't always point toward the same spots in the sky. In the next 26,000 years, it may cause the North Star to change from Polaris to a few other stars and back again. One day, the title of the North Star will go to Vega. It's the 5th brightest star in the night sky and the 2nd brightest in the northern celestial hemisphere. Vega has another name, Alpha Lyrae. That's because it's the main star of the Lyra constellation. Vega has been one of the most crucial stars to people since ancient times. It's very bright and blue, hence very recognizable. Vega was the North Star several thousand years ago, and it will regain this status in 12,000 years or so. This star is located a mere 25 light-years from Earth. It's just 450 million years old, which makes it way younger than our own 4.6 billion-year-old solar system. Astronomers study Vega to learn more about star systems in the early stages of their formation. Vega is almost directly overhead at mid-northern latitudes on a summer night. It hides behind the horizon for only 7 hours a day. You can see it on any night of the year. If you travel farther south, you'll find out that Vega lies below the horizon for longer periods of time. But in Alaska, northern Canada, and some parts of Europe, Vega never sets. Vega's blue-white light is bright enough to be featured a lot in ancient cultures, from the Chinese to the Polynesians to the Hindus. Vega's name can also be translated as falling or swooping. This is a reference to the times when people regarded this constellation as a swooping vulture, not a lyre. Vega was also the first star to get photographed, other than the Sun, of course. To do it, astronomers at Harvard College Observatory used a 38 centimeters refractor, and it happened in 1850. Around 2 decades later, an amateur astronomer broke down Vega's light to reveal various elements making up the star. In 2006, thanks to telescopic observations, scientists found out that Vega was whipping around so fast that its poles were several thousand degrees warmer than its equator. The star rotates every 12.5 hours and is at 90% of its critical rotation speed. That's the velocity at which an object can tear itself apart. In 2013, researchers announced that they had discovered an asteroid belt around Vega. It means there might be planets somewhere out there among space rocks. There are 2 areas, an outer region that contains icy asteroids and an inner region with warmer space rocks. Scientists can examine bright stars like Vega using NASA's mission called TESS, which stands for Transiting Exoplanet Survey Satellite. It was launched in 2018 to conduct an all-sky survey. The main goal of this mission is to search for exoplanets, but the satellite can also look for star variability. By examining such stars as Vega, TESS can help scientists learn more about the early stages of star evolution. Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet, so the future looks bright. We could use this water to support future missions, and then even relocate to Mars, since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least, that's what a new analysis of seismic data collected by the Mars InSight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past.
To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then, it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now we finally can find out more about the gooey center of the red planet. All thanks to the Mars InSight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves, generated by seismic activity deep inside the planet, can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 11 to 19 kilometers. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be, or what it could be like one day. And if once Mars had had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense, unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data have shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deeper below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds, and even more. Mars isn't the only place outside Earth where there is water, or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface. But it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold. So, it's no wonder there's a lot of ice there. The ice in these areas is also often mixed with the lunar soil and hiding deep below the surface. Then, there's Enceladus, the 6th largest moon of Saturn. In reality, it's not that large, just 505 kilometers across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then, there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 64 to 161 kilometers. And even though it's under a layer of ice that is likely to be from 16 to 32 kilometers thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there.
That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So, this massive cloud of water vapor surrounds a black hole, but not just any black hole. This one's a quasar located 12 billion light-years away from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe itself began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe. In May 2024, stunning auroras adorning the night sky demonstrated all the power that solar storms emit as radiation, but sometimes our sun does things that are far more destructive. I'm talking about solar particle events. During these events, blasts of protons coming directly from the surface of the sun can shoot out like giant cosmic searchlights. According to records, an extreme particle event hits Earth every 1,000 years or so. It often causes bad damage to the ozone layer and increases levels of ultraviolet radiation closer to the surface of our planet. Luckily, Earth's magnetic field acts as a powerful protective cocoon for our planet, fending off electrically charged radiation from the sun. In its normal state, this field functions like a ginormous bar magnet, with field lines rising from one pole, looping around the planet and dropping at the other pole. This pattern is sometimes called an inverted grapefruit. This vertical orientation of the magnetic field at the poles allows some ionizing cosmic radiation to get through the field as far down as the upper atmosphere. There, it interacts with gas molecules and produces the glow we know as auroras. But over time, Earth's protective bubble changes. In the past century, the North Magnetic Pole moved across northern Canada at a speed of about 40 kilometers per year. Plus, it weakened by more than 6%. Even more shockingly, according to geological records, there have been periods of time, as long as centuries and millennia, when our planet's magnetic field was super weak or entirely absent. But we'll talk about those tragic times later. It's easy to imagine what our planet would look like without its protective bubble if you look at Mars. The red planet lost its global magnetic field long ago. And once this field disappeared, most of Mars's atmosphere vanished too. In May 2024, a strong solar particle event hit the planet. It disrupted the operation of the Mars Odyssey spacecraft and made radiation levels at the surface of the red planet rise around 30 times higher than what a person receives during a chest X-ray. The sun's outer atmosphere constantly emits a changing stream of electrons and protons, the solar wind. At the same time, the surface of the star also produces bursts of energy, mostly protons, during solar particle events. These bursts of energy have a connection to solar flares, extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. Protons are way heavier than electrons and carry more energy. That's why they can reach lower levels of Earth's atmosphere, exciting gas molecules in the air. These excited molecules emit X-rays invisible to the unaided eye. Dozens and hundreds of relatively weak solar particle events happen during every solar cycle. Now, let's speak about solar cycles for a minute. You see, from a distance, the sun seems to be calm and steady. But if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in a repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole and vice versa. Right before this event, the sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period has the name of solar maximum. It's a rather dangerous time for Earth since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Anyway, back to our solar particle events. Researchers have found traces of extremely strong solar events happening throughout the history of Earth, and some of them were thousands of times stronger than anything our modern instruments have ever recorded. Such extreme solar particle events happen approximately every few millennia. The most recent one occurred around 993 CE. Beyond the immediate effect they have, solar particle events can kickstart a chain of chemical reactions in the upper atmosphere, and these processes often lead to depletion of ozone, which isn't a good thing. Ozone absorbs harmful solar UV radiation, which can damage not only our eyesight, but also the DNA of living beings. Plus, changing the amounts of ozone in the atmosphere can impact the climate. In a recent study, researchers used large computer models to examine how extreme solar particle events affect Earth. They found out that if a solar proton event arrives during a period of time when our planet's magnetic field is very weak, then ozone damage can last for 6 years. And the level of UV radiation might increase by 25%, boosting solar-induced DNA damage by around 50%. And apparently, this dramatic combination of a weak magnetic field and extreme solar proton events happens quite often. And some researchers believe that it may even explain a few mysterious occurrences in the past of our planet. For example, the most recent period of weak magnetic field started 42,000 years ago and lasted for around 1,000 years. This period included a temporary switch in the North and South poles. Several major evolutionary events happened during that time. For example, the last Neanderthals disappeared in Europe, along with the extinction of marsupial megafauna in Australia. Yeah, sadly, we won't see giant wombats and giant kangaroos anymore. One more, even bigger evolutionary event might also be linked to Earth's geomagnetic field. Multicellular animals appeared at the end of the Ediacaran period, which started around 635 million years ago, and it occurred after a 26 million year period of extremely weak or even absent magnetic field. The rapid evolution of different groups of animals in the Cambrian explosion about 539 million years ago might have also been related to high UV levels and geomagnetism. The simultaneous evolution of hard body shells and eyes in multiple unrelated groups could have been necessary to detect and avoid harmful incoming UV rays. A complete reversal of Earth's magnetic poles might have a serious impact on the climate of our planet. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. That's why the magnetosphere continues protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Our planet's magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges, called electrons, moving through the metal. The current is what generates a magnetic field. Earth's outer core is made of liquid iron and nickel. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving throughout the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic ray radiation, which, otherwise, would be extremely hazardous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. An asteroid broke off the moon, and now it's super close to Earth. Does it pose a danger to us? Kamo'olawa, also known as 2016 HO3, spins super quickly as it orbits near our planet. Let's call it HO3 for short. Astronomers found it on April 27, 2016. Compared to other asteroids, it's tiny. On Earth, though, it would be the size of a small building, or about half the size of the London Eye Ferris wheel. They discovered it in Hawaii, and its name roughly translates to a fragment of something that seems to wobble. After some study, they realized that this asteroid might be a chunk of the moon that got blasted into space. There's a part of the moon called Giordano Bruno crater, named after an Italian philosopher, that guy who had to pay quite the price for his ideas. If you look at it from space, Giordano Bruno stands out because it's surrounded by some rays of material. They're super huge, stretching over 150 kilometers, and are still bright. This means that an enormous boom once happened there. There's an interesting story about this. In 1178, 5 monks were traveling in Canterbury, England. Suddenly, they saw something strange happening on the moon. They said it looked like the moon was splitting, with flames and sparks. Then there was a darkening that spread all across the lunar surface. In the 20th century, scientists found these records and thought that these monks saw the formation of the Giordano Bruno crater. But later, it turned out that the crater's about 4 million years old. And thank the stars, because such a massive impact, if it really happened in the 12th century, would have gone crazy on our planet. It would have caused a huge meteor storm on Earth. In any case, our HO3 is most likely a piece of the moon that broke off during that impact 4 million years ago. Luckily, there's no need to panic about it. When astronomers spotted this sudden moon piece, they quickly tracked its orbit. Turns out, it won't collide with us anytime soon. It's going to be our quasi-satellite for at least 300 more years, meaning it will follow a path around the sun that keeps it close to Earth without colliding. Its orbit is wild, though. It seems to be constantly looping around our planet in some pretty unique loops, moving closer and going away up and down. And then somewhere in the 24th century, it will go even more crazy, switching to a horseshoe orbit, slowly going away from us. Could HO3 collide with us someday? Maybe. But that could happen over millions of years, when it could leave its current orbit and collide with Earth, Venus, or even the Sun itself. Or maybe entirely ejected from the solar system. Even though it's one of the closest asteroids ever discovered, it's also one of the smallest and most stable ones. This discovery also opens up some exciting ideas about life in the universe. We see that rocks can travel between celestial bodies. There's a theory that life could have been spread all across the universe by traveling on these rocks, like on some space Ubers. Or at least the building blocks of life, like carbon. Maybe life even hitchhiked to our planet on rocks from Mars. HO3 probably doesn't carry any life, but the fact that it can travel for millions of years, carrying stuff on it and feeling fine, supports this theory. Astronomers want to send something to investigate HO3. Back in 2017, a group of students gave an idea of using a spacecraft for it. The China National Space Administration wants to send a robotic probe to HO3 somewhere in 2025. The robot should fly there, collect samples and bring them back to Earth for study. Unfortunately, you can't see this asteroid in the sky with the naked eye. Its size is about 100 meters in diameter, so it would be too tiny and dim to see without a super powerful telescope. But there is an asteroid that you'll be able to see, and it will be insane. In 2029, a large asteroid will pass so close to Earth that it will be visible to the naked eye. Make sure not to miss it, because this is a once-in-a-thousand-year event. The asteroid is known as 2004 MN4, or Apophis for short. It's much bigger than HO3, about 369 meters wide. This will be the closest asteroid passage ever. This one actually caused some panic back in December 2004, all because there was a 2.7% chance that it could hit Earth in 2029. People were horrified. Even the name, Apophis, is inspired by an evil serpent from ancient Egyptian mythology, a huge monster that fought Ra and always tried to swallow the sun and destroy the planet. Luckily, when scientists got more data, they realized that it would pass pretty close to us in 2029, and we'd be able to see it in the sky. But then it will just fly away like a chill asteroid. There was another worry, though, that during its close pass, Apophis might travel through something called a gravitational keyhole. Basically, that it could travel through a specific narrow region of space, which would accidentally alter its orbit, and then it would make an epic comeback in 2036, like the planet from the movie Melancholia. However, after some calculations, scientists ruled out this possibility as well. Apophis will still come quite close to us in 2036, but it will be about as far away as Venus is when it overtakes Earth, and then Apophis and Earth will just go their own separate ways. On average, an asteroid the size of Apophis is only expected to hit Earth once every 80,000 years. If it did hit us, it would completely destroy a huge area, causing earthquakes and tsunamis all around the world. But it wouldn't cause an apocalypse or anything like that. You'd only be able to see Apophis from Europe, Africa, and Western Asia. So if you want to see it, you might need to travel. The asteroid will look like a fast-moving star in the night sky, shining bright enough to be seen without any special equipment. It would be easy to spot at night, though city lights might make it harder to see. Now, can you imagine that these are not the only guys hanging nearby? Both HO3 and Apophis are a part of the so-called Apollo orbit asteroids. These are the asteroids with orbits going around Earth. An entire group of dangerous fellas. Since they cross Earth's orbit, they have the potential to come close to or even collide with our planet. The first asteroid of this group to be discovered was 1862 Apollo, named after the Greek deity of the sun. It was first discovered in 1932, and the group was named after it. This one was even bigger, almost 1.6 kilometers in size. In fact, it's so huge that it even has its own tiny moon. Apollo crosses the orbits of not just Earth, but also Venus and Mars. Fun fact, even though it was the first one of its kind, telescopes accidentally lost it out of view for over 40 years. So scientists went, oh well, let's just keep the count of things we can see. When Apollo was rediscovered in 1973, it wasn't the first asteroid on the list and got a big number in its name. Apollo will fly near us during the next hundreds of years. In 2075, it will be somewhere around Venus, but it should fly by as well. In any case, there's no need to worry because astronomers are keeping a close track on these guys. If we were in any immediate danger, we'd have known. In order for an asteroid to totally destroy life on our planet, it should be bigger than 9.7 kilometers in diameter, like the one that helped to wipe out the dinosaurs 66 million years ago. But these guys are so crazy rare, we'd probably live on other planets by the time they arrive on Earth. Many sci-fi movies can make you believe that everything happening in space is accompanied by some kind of sound effect, which is a totally false misconception. In space, no one will hear you scream. There's no air in space. It's an almost perfect vacuum. And sound waves don't travel through a vacuum. They can't reach your eardrums and make them vibrate, sending signals to your brain. But it's a good thing, especially for astronauts on spacewalks. If not for the quietness of space, they would be constantly overwhelmed by the noise of solar storms. Huge space explosions sure look super impressive. Whether they're scientifically possible or not is another question. Blasts on our home planet look the way they do because of air and gravity. You see, the air functions as an oxidizer, and the outward pressure makes everything fly into the air and then collapse back to the ground. But this process is very different in space, and it looks even cooler. If a blast occurred in space, there would still be some fire despite the lack of air, because some kinds of fuels can act as oxidizers. But it wouldn't be the fire you're imagining now. This cosmic fire would look like an expanding ball of light. It would be a seemingly never-ending process due to microgravity and the lack of air resistance. Nearby spaceships would be in grave danger since the shrapnel would fly outward until something eventually stops it. All comets have beautiful long tails. It's nothing but a popular misconception. In reality, comets are very difficult space bodies to spot. They usually spend large amounts of time far away from stars. There, in the darkness of space, they remain rather inactive and completely frozen. Comets only get tails once they come close to a star. That's when they start warming up. This process makes them form some kind of a cloudy atmosphere, which is called a coma, and a distinctive tail. The tail always points away from the star that influences the comet. It happens because the tail gets blown in the opposite direction by solar radiation and solar winds. That's why the tail can often be in front of the comet, not trailing after it. The inner and outer planets of the solar system are separated by the asteroid belt, a ring of asteroids and other debris and space objects orbiting around the sun. While creating movies about space, filmmakers make sure to somehow use this region. Usually, they show the asteroid belt as an extremely crowded place, with dense clouds of huge rocks you have to skillfully maneuver through to get to the other side. In reality, if you looked outside your spaceship while flying through this region of space, it would feel as if you were looking at the sky from Earth, all because of the ginormous distances in space. If you decided to cross the asteroid belt, there would be very little chance of a collision with a space object. Asteroids there are really spaced out and very far from one another. Black holes are giant, scary cosmic vacuum cleaners, they say. But in reality, black holes are more like fly traps. They don't look for things to munch on. Instead, they sit out there quite passively. Only when a star, or any other object, comes too close does a black hole spring into action. Even so, only those space bodies that cross a certain border get ripped apart. In fact, black holes aren't any different from any other celestial body, since their pull is directly proportional to their mass. They can't swallow anything bigger than what their size allows. Even if our sun was somehow replaced with a black hole as massive as itself, nothing would change for Earth or any other planet in the solar system. Gravitationally speaking, of course. Space battles in movies often involve using lasers. But if you were to see such a fight from up close, you would probably be disappointed. The thing is, it would be like nothing in movies. A laser beam is a concentrated burst of energy, and it could indeed be used for many purposes during a fight. But a real-life laser beam would be totally invisible in space, since there wouldn't be any particles around to scatter the light and make the beam bright red or green or any other color. A human would be torn into pieces if they got into open space without a spacesuit. Well, contrary to popular belief, taking off a spacesuit during a spacewalk wouldn't be as dramatic as it is often pictured in movies. A person would just lose consciousness due to a lack of oxygen after 15 seconds of being in outer space without protection, but that's if this person breathed out as much air as possible. Otherwise, this oxygen would damage their lungs from the inside, making them rapture. After that, without the protection of the spacesuit, the pressure inside their body would drop. This would cause even more serious trouble, and even though this person definitely wouldn't burst, they wouldn't want to stay outside for too long. People often believe that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the moon orbits Earth, and the sun doesn't float away out of our home Milky Way galaxy. Astronauts on the ISS do experience the effects of gravity, but that's not full-fledged. It's microgravity. The gravity on the space station is only 10% weaker than the gravity on Earth's surface, but astronauts are constantly in free fall. The spacecraft, people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they're very different things.
A light year must mean time, right? Not really. Light years actually measure distance. NASA's definition of a light year goes like this: the total distance that a beam of light moving in a straight line travels in a year. And since light moves at a speed of 300,000 kilometers per second, a light year equals 9.6 trillion kilometers. It may seem as if the sun is always on fire. At least that's what it looks like in pictures and in movies. But in reality, our star is a giant ball of gas. Nuclear reactions happening in its core at all times make the sun burn. Every second, hundreds of millions of tons of hydrogen are converted into almost as much helium. During this process, huge amounts of energy are released as gamma rays. Then these rays turn into light. In other words, the sun does emit blinding light and incredible heat, but it's not actually on fire because no oxygen is involved in the process. The speed of light is believed to be the ultimate barrier for people when it comes to space travel, and it's often thought to be impassable. There are many theories about what it might be like to reach that speed, but none of the equations account for going above it. And still, we know that at least one thing in the universe is faster than the speed of light: the rate of its expansion. Yep, the universe is expanding faster than the speed of light, baffling astronomers and casual skywatchers alike. Or at least we can say so in terms of the speed of different objects, like faraway galaxies relative to each other. At the moment, it's not something scientists understand well. The rate of the expansion of the universe is proportional to how far something is too. The farther it is from us, the faster it's moving away. But even though we don't get the mechanics of it yet, we've got our proof, even though it's theoretical so far, that some particles might be able to travel faster than the speed of light. Some scientists think there could be more things out there in space that could challenge this speed barrier. All we need to do is find them.